Hello, welcome to my channel. I'm going to make a series of videos showing how to build a cheap alternative to the Flipper Zero, since it can no longer be sold. If you like this kind of content about pen testing, about security, subscribe to this channel. First off, I'm going to start talking about Flipper's features. So let's talk a little bit about the features of the Flipper Zero, right? One of the first features that Flipper has is a radio frequency, both the receiver and the transmitter, that operates below 1 GHz. Then besides, it has Wi-Fi, so it can also communicate on the higher bands, 2.4 and 5 GHz. Let's hit the beach. For SubGHZ communication, it utilizes the CC1101. In our project, we will use the same chip, the same transceiver. It also has RFID functionality. It can read cards, RFID, and NFC modules, thanks to NFC technology, both low frequency and normal, right? And it has Bluetooth too, which allows for BLE attacks. It also has infrared, so it can turn on and off devices using this technology. It supports micro SD. So it's a very versatile piece of equipment. In terms of NFC, it uses the ST25R3916. This chip is very much focused on credit cards. It's just that it's a chip that doesn't have much connectivity support, so it's a bit more complex to work with it. We're going to use a slightly more flexible chip for this feature, which is the M532. And what's interesting about it is that it supports both SPI and I2C, and we can already connect directly to our equipment. Well, the equipment line we'll be using is from AM5. AM5 is a company focused on IoT, and it works with various devices using the ESP32. I will briefly talk about each one and explain why we chose this line. The M5 is a line of modular equipment, and it's very interesting because all its devices, there's a GPIO connector on top. It also has a connector referred to as groove. Most devices use USB. This device here that I have in my hand is the M5stickC Plus. This guy is interesting because it already has Bluetooth, it already has Wi-Fi, and it already has infrared. So my plan is to use one of these devices with some additional modules, so we can perform the same functionalities as Flipper. Here we can put some kind of a shield or even directly connect boards. And we have some modules that directly connect here. The M5 line is pretty big, so we have several different devices. However, most devices can do the same things with it. So there's a bit of a change in capacity, functionality, memory. This here is an M5stickC Plus2. So this is the new version of this little guy. Essentially, it has double the space, and it also has double the battery life. It continues with the groove connector and a USB port. Here it has the same features, so Bluetooth, Wi-Fi. It also has a buzzer, so it can make a whistle. It has infrared microphone. This one has it too, I forgot to mention. We have a smaller line, which is the Atom line. This guy is much more economical. It doesn't have a display, but it has the GPIOs in the same way. There's the groove door, so you can use it. The memory is a bit smaller in this guy. We have a slightly bigger piece of equipment, which is the card filter. This guy is cool because it already has a, so essentially besides the SD card, it has this keyboard that we can implement some things on. I found it a bit large, okay? I think the M5stick is much more portable, so I plan to make a project with it, with one of these two here. Well, for radio frequency, we're going to use a C. The M5 line has its own module for radio frequency, However, it only works on 433 or LoRa frequency, so it's not that interesting for us. It also has an RFID module, but this module here is not very customizable. I can't do all the functions with it. Basically, it reads and writes cards. So instead of using this guy here, a groove connector, after using it, we will be using a PN532, which is this little board here. The PN is very interesting because it's extremely flexible. So if you look here at this pinout, I can decide if it's going to work with the ART with I2C or with SPI, depending on what I set in these pins here. In this case, I'm going to work with I2C, and then I'll connect it directly to the groove port using the groove cable. I'll be working with the CC1101 using the GPIO. So basically it will be connected here, and the other one will be connected over here. I'll also use a BlackBerry keyboard for some functionalities. So as I said, I intend to make something more modular. So if I need the keyboard, I plug in the keyboard, then I'm going to try to print a 3D case. To make this very modular, I need something more discrete, tiny. I just use this guy, maybe with the module I need. Try to do something in a snap-on way. Where can I dismantle and assemble my equipment and turn it into something very important? And then I need a keyboard, and I have this keyboard here. So my idea is not to always have it with me. This keyboard is interesting because it has a Kiwi connector, the Kiwi that I can transfer to the groove. So I already have a cable here, the groove EQ, and it will use the I2C protocol as well. So since my equipment has only one port and two Cs, we're going to be using a hubby. This hub allows me to use devices with different addresses. If the equipment has the same address, then I need to use a type B hub. This one is a type A hub. So having different 2C addresses, I can be using more than one device. Since we're only going to use different equipment on I2C, this solves our problem. In terms of I/O, this guy here doesn't have a SSD card reader. So I'm trying to make a project to use everything in the cloud. So my idea is to create an internet-based loader and make a partitioning where I upload the image as I need it, and then I dispose of it. Basically, in this equipment here will be a temporary partition, and a partition where the boot with my menu will be. And my menu accesses each of the functionalities on the internet. But if I need it, this is a general purpose input-output extender. So I also connect it to the groove port, and then I get more general purpose input-outputs for this equipment here, or any of them, right? So basically that's it. That's why we're using this line, the M5 lines. It's pretty easy going, very modular and flexible. And now in the next videos, I'm going to show how we can toss an image into these devices here. Thank you very much. If you like this video, subscribe to the channel.